talk about unsupervised learning and k-means clustering using Python. So in this tutorial we'll go over k-means and the variations and the flavors of k-means and what parameters are used in k-means using Python. We started in the first cell by including some important packages that we will use during this tutorial. And then in the first example we will just take a random data. So we used a function that's called make classification to generate 1000 examples. Each example will have two features, and we have some parameters just to make sure that we have a meaningful data for the sake of this example. Now we save this data within X and we do not care about the labels, so we just discarded the labels and we printed the shape of the training dataset or the given dataset that we have. And the shape, as you can see it in here, is 1000 by 2. So we have 1000 examples and 2 features per example. Then we made a scatter plot to show the relationship between the two variables or the two features within this dataset. As you can see it in here, it's mainly categorized into two or clustered into two components. One to the right in here and the other one is to the left. Then we constructed k-means. So k-means is a function that already exists in sklearn in Python. And to construct it, we started with a k-means, which is the function name. And then we specified the number of clusters using n_clusters. In this example, we are using 3 clusters. Then we used n_initialize, which is n_initialize is the number of initialization or the number of times that the k-means algorithm will be or will run with different centroid seeds. So how many times would you like to run to randomly initialize your k-means randomly and then run it, and it will retain and keep the cluster with the initialization that performs the best. The default value to this n_initialize is 10. If you would like to have more accurate data or more accurate clusters, you can increase this n_initialize. Like just make it, for instance, 1000 or 100. But that will slow down your algorithm, or the time that will take. It will take more time to run your algorithm. Maximum iteration. The maximum iteration is how for each randomly initialized experiment, how many times would you like to keep iterating and changing the means within the algorithm itself. So the maximum iteration in this scenario is 300. So you can increase it as well. And if you do not use it, the default value will be 300. Verbose, it will be if you would like to display and print the operations while you are running the experiment. It can be 0, it can be 1, or any value that you can evaluate it to 0, 1, and 2 and see what the output will look like. Now, after we created the configuration and the settings for the k-means, we can go ahead and fit the k-means on the dataset. So the dataset was X with 2 variables, so we fit the k-means with 3 clusters on the model, and now this initialize or created the centroids or the center data points or 3 center data points for our dataset. Then in the next step we use to predict. We use the model.predict. So this will use the k-means or the centroids within the algorithm that we fit on the training dataset and try to assign the closest cluster label to each example in the dataset X. So now y hat includes these labels. Clusters equals unique y hat. This will retrieve the unique clusters so we can plot them. And then we used we visited every single cluster within our clusters or unique clusters. And then we use the function that's called where. This where function will find the index of a certain values within an array, and then I plotted the clusters on a scatter plot, where the clusters that are with the same label or the data points within the same cluster are having the same color. And as you see in here, we use the 3 clusters, and therefore we see 3 colors. So this is one cluster, this is second one, and this is the third cluster. Now let's try to play with the number of clusters, and maybe we can use 4 clusters and see how that will be performing. So we use number of clusters equals 4, and we left all other parameters to be the default values. And now I fit the parameters, fit the data on the model to find the centroids, and then I predict the values for x, and I've done the same and printed the values. So as you can see in here, we have these are four clusters, and if you see this portion or this small portion of the data is kinda mixed between, it's within or between the green and blue, and it's clustered as red. So let's try to change the variables and just set it, instead of 0, just set it to 1 and see how will that change. So you can see in here, this is the iteration, and the inner TIA is the value or the quality of the cluster itself. So it's how far is the distance between the centroid and the data points that belongs to that centroid or clustered within that centroid. So you can see the values has been changing, and they will be reduced because we are minimizing the distance between the examples and the data points. And this is the variables for the k-means after certain number of iterations. Let's see, do we have 2? I'm not sure if we have 2 or not, but we can try 2, and you'll see it's more details. You can try 3. So it looks like it will be either 0 or 1. So 1 is more details, and 0 it will not have any details. Let's try to increase the clusters more and use 5 clusters. If we use 5 clusters, so this will divide our data much more, and you can see in here the data has changed. So let me just run it again, just make sure that we have the same data set. So this is the data set that we have. So this is the data set. So I clustered the data in here. It looks like I changed the data somewhere. Okay, so this is predict x, and this is if we have 5 clusters. So as you see, we have now orange cluster, we have the blue, we have red, we have green, and we have the third color in here. So we have 5 different colors or 5 different clusters. So you can also reduce the number. So instead of using 5 clusters, how about if we use just 2 clusters and see how that will cluster our data. So you can see our data. I expected the data to be separated as this is one cluster and this is the second one, but it was like 2 clusters, like dividing the data into 2 halves. Now let's increase it even further and just use 10 clusters, or you can use like the same number of data points, like 1000 clusters, and that will provide you with a different color for each data point. So now you see the separation of the data and how they are categorized. This dataset is a synthesized dataset, or it's a random dataset that we generated using a function. So let's see if we can cluster a natural existing data, such as the iris data that we used previously in the previous videos. So the iris data includes three classes. So 3 classes of roses, and each data point or each example includes 4 features. So the data set is 4 columns or 4 features, 150 data points or 150 different examples, and they are categorized or clustered into 3 different or classified into 3 classes or 3 different classes. So let's load this data and try to play with it and see how we can cluster it. So I retrieved all of the data using datasets.loadIris. So datasets is an object that we imported from sklearn, and then I retrieved the iris data, and I am interested only in the actual data points. I don't care about the labels at this moment because we are unsupervised learning, so we do not care about the labels, we just care about the data points. Now I know that the iris dataset includes 3 clusters. So what I want 3 classes, sorry. So I expect them to be in 3 clusters as well. So I would like to classify a cluster the iris data into 3 clusters, and then fit all of the iris data on this uh, with three clusters, and predict the to which clusters or assign every example to the corresponding cluster. Then we try to identify the unique clusters and plot every cluster data points using one color. So this is the iris dataset, and since this data is in 4D, in fact, so we have the data in 4D, like we have 4 variables within the data, or 4 features, and we are trying to plot it or use a scatter plot, which is 2D, to plot it, which will not make sense, and this is why we see the data like this. However, we are still seeing 3 different clusters within the dataset itself. For simplicity, let's try to just isolate and retrieve only 2 features out of this data. So let's retrieve the first 2 columns from the data and try to play with them and see how we can cluster them. So what I have done in here, I reloaded again. I loaded the iris dataset. Then I retrieved only the first 2 columns of the dataset. So we have 2 columns and 150 examples, 150 rows in the data. So I try to print the shape, and you can see in here we have 150 rows and 2 columns. Then I retrieved the labels of the dataset, which are the targets, and then plotted the dataset using a scatter plot, and this scatter plot will try to print, or it will plot the relationship between the first variable and the second variable, and it happens to have the first variable as the sepal length, and the second variable is the sepal width. So we have the x-axis is the sepal length, and the y-axis is the sepal width, and we have the labels in here, the actual labels of the data, because the data is already labeled. It's a supervised learning data set. So we try to plot them, and you can see that this is a cluster that belongs, and it's already related to each other, and they have the same label except this data point. Now the other 2 classes, they are mixed, so you can see there is a like a sort of cluster in here and another cluster in here, but there is in between some data points that are mixed between the 2 clusters. Now we would like to use the elbow method to decide how many clusters we should cluster this data into. Now we know beforehand that this data is already separated and labeled into 3 categories. So therefore we know the ground truth. So let's use this elbow method for finding what will be the best number of clusters for this data point. So I created an initially empty list or empty array, and then we decided we will cluster the data between 1 cluster up to 11 different clusters, and then we will see where the elbow appears, and that will be the right number of clusters that we will use. You can use more than 11, but our data set is very small, so 11 should be good enough. Now within this for loop that iterates from 1, 2, 3 up to 11, and this will create 11 from 1 cluster, 2 cluster up to 11 clusters, so we run the algorithm 11 times. Then we fit our model or we create a configuration for our model with the cluster equals I. So 1 time with 1 cluster, 2 clusters, 3 clusters, and so on. Feel free to use other types of initialization or initialize other parameters, but I will leave them to be the default values. I just added this, made them as comment. Then at each iteration within this for loop, we will fit our data to the model, and then extract the rest of parameters for each model. And once we extract the parameters, we will save the criteria or the sum of squared distances of samples to their closest cluster center. So this will find sort of the objective function that we have for the k-means. So this is the criteria that we have in here. So we will save it and append it at iteration 0 or iteration 1. The first element will be the criteria for the first element or for the first cluster. If we have 2 clusters, then we will save the value of the cost function as the second element in the list. For the third cluster, we will save the objective function evaluation in the third position within this list, and so on and so forth until we are done with the 11 experiments, or 11 sizes, or 11 clusters. Now once we are done, we will take the relationship between the number of clusters, which is the x-axis, and the y-axis will be the sum of squared distances. And as you see in here, this is the plot that we have, and it looks like our elbow, or the elbow, appears at either between 2 and 3. So it's mainly the 3 data points. So you can try 2 and you can try 3, but I will go with the 3 in here, which I believe is the elbow point. And as you can see in here, we already know about this data point, or this example, which is the iris dataset. It's already categorized in 3 categories, and this elbow method confirms the idea of the idea of finding the right number of clusters. Now remember that we extracted our x now as the first 2 columns within the dataset. So let's try to cluster them and see what we get. So we will cluster the first 2 and compare them against the actual labels of the dataset and see, does the k-means find the right number of clusters, and does it group or categorize related examples together? Let's see that. So we created k-means, and we set the configuration for this k-means to have 3 clusters, and then we fit the training dataset, or the dataset of the 2 columns and 150 different examples on this k-means. Now we have like out of the model itself, so the k-means model that we fit before, you can use dot labels, and this will provide you with the associated cluster number to each example. So in this scenario, new labels will contain 150 different values, and the values will be 0, 1, and 2. Because we have 3 clusters, so cluster 1 will be numbered as 0, cluster 2 will be 1, and cluster 3 will be as value of 2. We will see it in a minute. Now, we created a plot, and this plot will include 2 subplots. So these 2 subplots, we decided we will create use a plot. We already imported a plot up if you go to the list of packages from matplotlib. And then we created 2 subplots. The subplots that we have, it's 1 row and 2 columns. So, and this is what I'm talking about. So we have 1 row and 2 columns. Each cell will be represented by a plot. So this is what we have done in this subplot. In the first subplot, we can reach it by using axis of 0, and the second subplot we can reach it by using axis of 1. So axis of 0, we will use a scatter plot, and in this scatter plot we will plot the original data. So we will plot the original data where we will have the relationship between the first data points, or x of 0 and x of 1, and the actual values, or the actual colors, will be the colors of the actual labels. So plot 0 will have the actual labels. Remember that y was the original labels that we extracted and removed from the dataset, and then we added some parameters just to show different colors. Then the second subplot will use the same x0 and x1, which is the first column and the second column, and then the colors will be using the new labels. The new labels are the labels that has been associated, or the cluster number that was assigned to the examples. And then we use some sort of colorings and used other like parameters just to play with the plot and make it nice and neat. Then we assigned the x label and the y label for each data, for each x and y axis of the subplots, and we added some sort of some cosmetics that we added to the subplots. Now after we plot the data, you see on the left hand side, or the left subplot, we plotted the sepal length and the sepal width for both of the plots, and the left one is the actual labels that was originally provided with the dataset. So as you see, we already have seen the same plot before, a few cells before, and this is class 1, class 2, and class 3. whereas the predicted labels, as you see it in here, we have this, it looks like this has been predicted correctly, totally fine. But the other two classes, if you remember, they are overlapped. So you see there is an overlap data point somewhere in here. So, and the k-means was unable to identify the the data points with the overlap. So therefore, it created a clear cut or a clear separation, or a clear boundary of separation, because it cannot find if a data point is within another cluster. So therefore, we do not see a clear cut with the k-means, unlike what we see or what we used to see in the classification and the supervised learning. Now, let's look at the assigned clusters for each example. So I repeated the previous experiment. So I loaded the iris dataset, but this scenario I loaded all of the data points. I loaded the 4 columns and I retrieved the data. I applied k-mean clustering with 5 clusters in this scenario, and then I fit the model on the dataset again, which is the iris. So initially I configure the k-means in line 4, and line 7 we fit the model that we configured into the dataset, which will create list of parameters, as well as, and the parameters will be the centroids and the labels for the training dataset. Now I used dot labels underscore just to show you the associated clusters for each example. And remember, we have 5 clusters, so therefore the clusters are numbered from 0 to 1, 2, 3 up to 4. 5 different clusters, 0 based, and that will mean we are from 0 to 4. And these are the 150 data points and how they are labeled, and the associated clusters for each data point, or associated cluster. In fact, it's just one single cluster for each data point. Now you can fit your model again and then try to associate a new data point to one of the existing clusters that has been determined and decided by the k-means and the dataset that we used initially. So for instance, I loaded the iris dataset again, and then I fit k-means with 5 clusters, and I fit the data of iris on that cluster, and then I try to see the data points of 1, or the data point of 1, 2, 1, and 4. Which cluster does it belong to? So it's very close to cluster 1, which is the second cluster. How about this data set of 5.9, 3.0, 5.1, and 1.8? It looks like this one belongs to cluster 3. Now I would like to confirm in here. As you can see in here, I opened double parentheses and I closed double parentheses just to indicate that this is a 2D list. So if you would like to predict 2 data points together within one list, so you have this inner list is one data point, and this is second data point. All of them are in one data point in here, and try to find the associated label with it. And this scenario is 2, and you can just extract that actual value by just treating it as an array, or you can provide a list of data points in the form of a NumPy array. So these 3 data points, this one is associated with label 2, or sorry, with cluster 2. Cluster 2 is the third cluster. The second data point is associated with, or labeled, or close to the centroid of the first cluster, which is cluster 0. And the last data point in here is very close to the third cluster that has the number 2. Now let's see how we can extract the cluster centroids. So the cluster centroids can be found by using the method or the property that's called cluster underscore centers underscore. Let's see how we can use it. So to find it, we will just extract iris data again. Then we will apply k-means. Let's just assume we have 3 clusters. Fit the data, and after we fit the data, we will retrieve from the model dot cluster centers. Excuse me. The cluster centers will be like the number, it will be n by n, or a matrix, and this matrix will have the following. Well, the number of rows or the number of centroids will equal the number of clusters that you have declared. So in our scenario, we declared 3 clusters, so we expect to see 3 different centroids. So we'll have 3 different rows within our data, and the columns in the centroids will be equals to the number of features or variables in the original dataset. So our original dataset includes 4 variables, so therefore we expect to see 3 rows and 4 columns. So when we created the centroids, now we have 3 by 4, which is the number of centroids that we have. As you see it in here, I tried to print the cluster centroids is the centroids dot shape. And in fact, let's try to print the centroids. Like, let's show you how they look like. So they look like as a 2-dimensional array, a NumPy array, and this array includes every single element is a centroid or a centroid for one cluster. Then just to print them, I used enumerate within a for loop. So this for loop will take the index and the actual value, and it will visit every single value within the list of centroids, and it will print the index. So I use the index as idx plus 1 because I would like to start at base 1. So say centroid 1. So it will be, index will be 0 plus 1, it will be 1. So centroid 1, and I printed the centroid. So this is the centroid of the first cluster, this is the centroid of the second cluster, and this is the centroid of the third cluster. Let's just make it 5 clusters and see how that will be different. So as you see in here, we have 5 by 4 because we have 5 clusters, and every cluster will have 4 data points. This is all about k-means and unsupervised learning. So you now should be able to retrieve any dataset, cluster it into any number of clusters, and play with the hyperparameters to see how you can optimize and how you can get the best clusters within your dataset, or to cluster your dataset.